Hi everybody, welcome to lesson 4.1 part 1. Today we are going to talk about basically half of the lesson and we are starting on page 39. You are definitely going to need a pencil, and another thing you may want to have, if you have one, a ruler, and you also will want a calculator today of some sort, okay, potentially. All right, now we've talked a lot about theorems so far and definitions, and something else in geometry that's really important are postulates. And basically what a postulate is it's just something that's accepted true without any proof. It's basically like a definition or something that this is a starting point that we just know is true, that we accept, okay, without necessarily needing proof about it, okay? One thing we talk about in all of math, not just geometry, but it's distance, okay? And kind of like point, line, plane, distance is an undefined term to us. And what we've talked about a lot so far is when we talk about a line segment and we want to name a line segment, we would say, for instance, segment AB with the segment bar on the top, right? This means the segment. If we just say AB without the segment bar, this means we want to calculate the distance or the length of that segment. Okay, so think about when you measure something with a ruler, we were going to measure segment AB. We would say the length of this is 5 inches in this case. Okay, and that is talked about a little bit more in this reading math box that you'll also see on page 39. Okay, now this next piece here is going to talk a little bit about lengths of these segments. So what number one wants you to do is to measure, whether you have a ruler at home or if you need to use the one that I have right here, but you want to use the centimeters part of this. Notice it says in the instructions, measure each length in centimeters, how long each of these segments are. So I'm going to put this here for those of you that don't have a ruler, but to measure what is the length of DE, EF, and DF. Again, notice there isn't a segment bar because we want to find the length. Okay, so take a moment to calculate that. We also want to calculate using the centimeters, again, the lengths of KH, HG, and then the entire segment GK. Now, you may or may not be noticing a pattern here, but I'm going to give you guys a second to notice. If you look at 4.9, 5.7, and 10.6 on this page, or the lengths on the previous page, are you noticing about any patterns between these? Okay, and these again are just kind of approximately what you should have gotten. Hopefully you answered that you are noticing that when you add up the lengths of the two smaller segments, the two shorter segments, they're equaling the length of the biggest segment, in this case GK up here. Okay, so what that actually leads us to is our first postulate that we're going to talk about, and that's the segment addition postulate. And basically what the segment addition postulate tells us is that what I like to call small guy plus small guy equals big guy. If we have a segment named MP, okay, and N is a point in between N and P, then the length of MN plus the length of NP has to equal the length of MP. Okay, so like I said, what I like to call this is small guy plus small guy is going to equal your big guy. Okay, it's another way of thinking about that. Now, each time, what you want to do, and it's going to seem annoying, but it will make these problems immensely easier, is draw a picture. I am telling you right now, draw a picture. Okay, read your information and draw a picture. So for instance, in letter A, it says that segment B is between C and D. Now, something important to note here is this segment addition postulate only holds for collinear points. So they're always going to be on the same line, right? Collinear points only is how this is going to work, okay? So notice when we draw this picture, if it says B is between C and D are our endpoints, B is somewhere on here, and they're telling us B to C is 10, B to D is 3, and they want us to calculate the entire length from C to D, which is going to be 10 plus 3, so 13 units, okay? Now in the next example, again, we're going to draw our picture. It says Q is between R and T. So we're going to label our picture R and T. Here's Q. This time it says R to T. This whole thing is 24. And then it says that QR is 6. And now we want to know, well, what is QT? This time you're not going to use addition. You're going to use subtraction, because 6 plus our unknown length is going to equal 24. So we would have to subtract to get our final answer of 18. Okay. Now from here, we are going to start combining numbers with algebra. Okay, so here is a picture. It says that P is between L and A. So here's L, here is A, and here is point P somewhere in the middle. Now PL, they are telling us, is x plus 4. PA is 2x minus 1. And LA, this whole thing here, is 5x minus 3. Okay. Now going back to what we talked about up above here, small guy plus small guy equals big guy. So in order to solve for x and eventually the length of our segment, we're going to take our two small guys, x plus 4 and 2x minus 1, and we're going to set that equal to 5x minus 3. Super important that we have this picture, because otherwise we might not know which one's small guy, and which one's big guy. Small plus small equals big, okay? Now from here, we are going to solve the equation. So we're going to take our x's on the left-hand side and combine them. So x plus 2x with 3 x's, and then 4 minus 1 is 3. And then now that everything is condensed, we can start solving. So from here, I'm going to subtract the 3x to the other side. And I'm also going to add my 3 to both sides so that I have something on each side. And then last but not least, when we divide, we get x to equal 3. Okay, so that's part of this, is it wants what x is, which was 3. The other piece this wants is what is the length of L to A. Okay, and a reminder, LA is going to be taken by plugging in to this 5x minus 3. So to find LA, we're going to take 5 times our x, which is what we found to be 3. We're going to subtract away 3 from that. So 15 minus 3, LA is 12. Okay, so there are our two answers. So there's two pieces to this. Make sure you answer them both. Now, another really important vocabulary word that we are going to see throughout this class is the idea of a midpoint. And a midpoint is a segment that is a point that cuts a segment into two congruent segments. And you're probably like, what the heck is congruent? Congruent is a fancy geometric way of saying equal, okay? So congruent, you might want to think about as equal, right? Equal measurements, equal size. The congruent symbol looks like this. Okay, so sometimes that's how you'll see it shown. Now, when we have congruent segments, what we like to do is we like to mark them with tick marks. So notice A to B and B to C, those are both 3. So to show that on our picture that they have the same length, what we're going to do is we're going to put these tick marks on our picture to show that A to B is equal to B to C. Those segments are the same. Now you might put 1 dash, you might put 2 dash, but if they are congruent, you're going to want to mark them so that this and this have the same amount of tick marks, okay? So in practicing here again, if we have a segment RS and they are telling us that M is the midpoint, just like we drew before, we are going to draw R to S, but this time because we know M is the midpoint, we're going to draw M in directly in the middle, and we're going to mark our picture with that. Because we have the keyword of midpoint, we can put those tick marks on there, okay? Now, they're also telling us that RS, this entire thing, is 10, which means R to M and M to S have to be equal, aka both 5. So S to M, this length, is 5. Now, if we draw another picture for the second one, right, we have, again, same given information, R to S, M is the midpoint, mark our picture to show those congruent segments. If RM is 12, that means MS is also 12 because it's congruent, and our whole segment here is 12 plus 12, small guy plus small guy, aka 24. Okay. I'm not going to do all these, but a couple other things I want to talk about here is the idea of our a point being on a number line. Okay, so notice if we have a number line, if we have a line here, just drawn a line, D and E are aligned on the ruler, and point D is 4.5 centimeters, and the distance between D and E is 3.4. Okay. Well, at what 2 marks could point E be located at? Because officially point E could be located here, or point E could be located over here. They're not specifically telling us where it's at. We just know that point D is at 4.5. Okay. Well, if the distance between them is 3.4, what that means is we could officially be going 3.4 units to the right, or we could be going 3.4 units to the left. Okay, so the 2 possible locations that we could have is 4.5 plus 3.4, which is 7.9, or we could have 3.4 to the left, aka subtracted from 4.5, which would leave us at 1.1. Okay. A little bit of reasoning abstractly is, are any rays going to have a midpoint? Well, the answer here is no, because reminder, with our rays, we're going to infinity and beyond, basically, right over there, because of that arrowhead. Oops, because of this arrowhead here. So can a ray have a midpoint? The answer here is going to be no, because one direction of the ray goes to infinity. And there is no such thing as dividing infinity in half, right? So there isn't one. Only line segments are going to have a midpoint. Okay. Now, last but not least, today we're going to finish up talking about our length in the 4.1 lesson here by looking at this number line, okay? Now, again, they're asking us to start here by what is the length of segment LM. Well, if I'm going from -3 to 0, that's 3 units. plus another 4 units. This has a total length of 7 units, right? 7 units is how much we had to move here. That's our length. Now, moving on to that, if we look again here, where's the midpoint going to be of our segment here? Well, the total length from 8 to 40 is 32 units, right? So halfway between 8 and 40, we have to go half of 32, aka a total of 16 units, right? If we take 32 divided by 2, we'd have to move 16 units from 8. So I'm going to move 4, notice our scale, 8, 12, 16. My midpoint would be here at 24. So when it says, what is the coordinate? We would say it's located at 24, right? That's the location. Well, they show us that then on the picture below. So what we want to do now is that same process here for number 13. Well, from K to L, we start at -9 and move to 0, that's 9, plus another 15. 9 plus 15, KL, is a total of 24 units long. The coordinate of the midpoint then, that we talked about up above, is halfway between K and L, aka half of the total distance, which is 12 units. So we need to move from -9 to 0 plus 3 more to get that midpoint, we'll call that M, which is going to be located at 3. So midpoint is at 3 on the number line. And again, that's different than how long this is, okay? Now from here, it says we have a new point. We're going to call this point C. We're going to make him the green point. And it's between K and L. And it is 1/3 of the distance between K and L. So a reminder, KL is 24 units long. 1/3 of 24 is 8 units, okay? So if we want to place point C, we need to move 8 units this time from K, so that we would actually be here at -1 would be point C. So for part D here, C is located at -1. And then last but not least, we have point N, which is 3/4 of the length from C to L. So notice from C to L, we would have to move from -1 to 15, which is 16 units, okay? Well, 3/4 of 16 units is 12 units. And again, if we're moving now from point C to point L, we need to move 12 units to the right, which is going to actually put us at, from -1 plus 12, we're going to actually be at 11. At 11 on the number line, okay? Try your best on these practice problems, and we'll keep working more with this before we move on to part 2. Thanks, everyone.